Am I recording now? Hello everyone, hi, this is your resident mathematics teacher, Sir Cash Casatibadenes, Special Science Teacher 1, teaching mathematics at Puerto Princesa City National Science High School, and today I will be discussing about logarithmic functions. Logarithmic functions is actually the last topic of the first quarter in general mathematics because after this lesson, it's actually second quarter. And after this lesson, we will be having a new topic which is actually business mathematics. And before anything else, before we start, I would like to apologize for the low quality of my camera and my lights because I haven't received the mini HDMI that I need to use my DLSR camera for my webcam. And so since my face is small for the presentation, so I guess it's okay. So that's it. Let's have logarithmic functions. I hope that you already know the topics before this topic because it's actually quite useful for you. Okay, let's go. Okay, so now, okay, let's have this one. Definition of a logarithmic function. So a logarithmic function is a function defined by logarithm or y is equal to logarithm of x with a base b. You heard it right. Y is equal to the logarithm, which is the log here. If you can notice, we have log here, right? Okay. So where's the cursor? Okay, so we have so this is read as y is equal to the logarithm of x with a base b. So it's y equals logarithm of x with a base b. And it is only possible if x is equal to b raised to y. For all positive real numbers x and b should be positive real number, and b should not be equal to 1. Okay? Okay. So I know that it's quite hard for you if you just see this kind of function because not all of you really know what is a logarithmic function, right? And we all know that logarithms is logarithms, and you all think that it's difficult. So what is really a logarithm? Okay, before we proceed, let's first define what is logarithm. So a logarithm is actually a number. Actually, it's a notation of number wherein this notation lets any extremely large or extremely small numbers be expressed easily. Okay, it might be the weight of the sun, or maybe the particles that we have in the sun, or the distance between the earth and the another galaxy that is in the another galaxy, right? So those numbers is quite large, or even the size of the grain of sand compared to our body. So that is very, very extreme numbers, extremely large or extremely small. So the job of of logarithm is to express those large numbers or those small numbers into an easier notation. That's why we have logarithms, the log, okay? And since it's a number, of course, it is present in an equation. That's why we have here, again, it is read as y is equal, sorry, where was that? Y is equal to logarithm of x with a base b. Okay? And if you all know, if you didn't know, and if you didn't know why, and if you didn't know, logarithm function is the inverse function of the exponential function. Okay, that is correct. Because we have an exponential function. We have x is equal to b raised to y. This is exponential, and any exponential function or equation can be rewritten or can be rewritten rather can be rewritten as a logarithm or logarithmic equation or function. Okay, so I know that you haven't get what I'm talking about here. So now, let us know how to convert an exponential equation to a logarithmic equation. So given the equation b, here we have b raised to x is equal to n. That equation, b raised to x is equal to n, can be converted and can be written as logarithm of n with the base b is equal to x. Okay, remember the parts of the equation? We have here the exponent. We have here, the x here is exponent. B here is the base and n here is the the answer or maybe the number. Okay, so let's erase this first. Okay. So the base in the equation or the base in the exponential equation would still be the base in the logarithm. That is said as base b because it's still the base. Kung ano pa yung base, siya rin yung base. The answer would be the one who is the what? The the quotient maybe or the n here will be the one who will be needed to be logarithm to be transformed by the logarithm to get the x. Okay, para tayo nagdi-division pero in a way that it's exponential and logarithmic. And of course, the exponent will be the answer. So palit lang to sila. Okay, nakuha ba ang and then the b here will be the base. O, tignan nyo na lang. I guess by observation makukuha nyo naman siya, di ba? Oh, the very technique here is that interchange n and x when you write it in logarithm, and b will retain as the base. Okay, so I have here a lot of exercises. So let's have some. Or okay, let's have first an example. So in exponential function, we have here 2 raised to 2 is equal to 4. So 4 becomes here or is here. And then the base 2 is here. And then the exponential 2 is the answer. The same way goes with 10 raised to 3 is equal to 1,000. So the 1,000 becomes here. So logarithm of 1,000, what is the base? Base 10. And the answer will be the exponent, which is the 3. Okay, observe these two numbers. It's the same, right? We have logarithm of 5 because that's the answer. With the base, what's the base? 25 is equal to the exponent 1/2. Same way goes with here. The logarithm of 16 with the base, what's the base? 4. And the answer is the exponent is equal to x. Okay. So that is how we rewrite exponential to logarithmic and vice versa. Okay, if we have logarithmic function, we can rewrite that as an exponential function. Okay, so complete the table below. We have here exponential functions and logarithmic functions. So all we have to do is to write the logarithmic form if given the exponential. And if the logarithmic function or the logarithmic form is given, of course, we will write the exponential. Okay, let's have this example. We have 5 raised to 0 is equal to 1. So that will become the logarithm of 1 with a base. What's the base? 5 is equal to 0. Is that correct? That is correct. Okay, so let's have it zoom in for you to see. How about this one? The given now is logarithmic. So we will rewrite that as exponential. So we will be having, what's the base? Okay, very good. So what is this? It will become our exponent. So that is k raised to n is equal to, the middle part will be the answer. So p. K raised to n is equal to p. And that is correct. Now, we have still here, we have here exponential function again. So we will write that as logarithmic form. So we have logarithm of, what's the base? Or first, oh, what's the answer first? 32 with the base, what's the base? 2 is equal to, what's the exponent? 5. Very good. That's correct. We still have 3 more. So we have 3 as the base. The exponent is negative 2 is equal to 1 over 9. That's correct. How about next one? We have 4. The base is 4 raised to 3 is equal to 64. And lastly, we have logarithm of m with a base b is equal to n. So that is the answer. If you see that, or if you are unsure of your answers, just check it if it's really correct or if really makes sense. Just like for example, if we have here logarithm of 1/9 with a base 3 is equal to negative 2, and you um have the exponential function, try to check the exponent if it yields the correct answer. Try to check that 3 raised to negative 2 is equal to 1 over 9 or 1/9. Or is 3 raised to 1/9 will give you an answer of negative 2. So if it's wrong, definitely your answer or your form that you have written is wrong. Otherwise, if it's correct, therefore your form is correct. Okay. So let's have next slide. I sorry. Okay, sorry. Okay. So that leads to our definition. The logarithm x of a number n to the base b is the exponent of the power to which b is raised to obtain n. So in symbols, if we have logarithm of b of sorry, if we have logarithm of n with the base b is equal to x, therefore we have b raised to x is equal to n, and vice versa. Okay, very good. So now we will be having two kinds, or let's say it's not really two kinds, it's three kinds of logarithm. So we have three kinds of logarithm. Okay, so pardon for my writing because it's actually not good. Okay, so so we have three kinds of logarithm, sorry, I misspelled it right. So one, we have simple logarithms. When we say simple logarithms, these are the logarithms that we actually use, just like in the example earlier. It could be base 4, it could be base 2, it could be base 1/2, or any number that is not 0, and it's not also a negative number, and it's also not equal to 1. Okay? So it's any number. As long as it's not 0, it's not negative, and it's not 1 as the base, that is a simple logarithm. Okay? Number 2 is that we have common logarithm. Common logarithms is actually common. Why? Because these are the numbers that we see actually in science. And it's not really in the form logarithm, but that is the one application that we have, because common logarithms are in the base 10. Okay? So if we have logarithm of 9 with a base 10 is equal to x, for example, since it's base 10, it is in base 10, therefore it is a common logarithm. And the thing is, if it's a logarithm with a base 10, we didn't write 10 here. Instead, it's simply okay if it's just logarithm of 9 is equal to x, because it is understandable that in logarithm that we don't have any bases, the base is 10. Did you get me? Again, if you didn't see any base, any number that is, it don't have any base, and it's logarithm, therefore, the base of the logarithm is 10 because it's considered 10. Remember that you have exponent. X has an exponent, right? What's the exponent of x? It's 1, right? But we don't write 1 because it's considered as 1. In logarithm, if you don't see any base here, the base is considered 10. Just keep that in mind because that is actually important. Okay? Why it's called common logarithm? Because it's common. Scientific notation. Remember? If we write scientific notation, it is in the base 10. It is in the power of 10. Let's say, for example, we have 3 times, sorry, it's not writing. So we have 3 times 10 raised to 3 or raised to 4. The 10 here is useful in common logarithms. That's why the reason it's called common, because of the 10 here, which is actually omitted. And it's not written actually because it's considered. And the last kind of logarithm, sorry, I need to adjust so that for you to see, we have natural logarithm. So what is a natural logarithm? A natural logarithm is actually not natural. It's not related to nature, but it is just called natural logarithm for some reason maybe. Because here in natural logarithm, we have the logarithm that is with the base e. So if we have logarithm of 3 with the base e is equal to x, therefore the logarithm of e here is a natural logarithm. The thing is, just like in tens, we don't see logarithm with the base e here. Instead, it sorry, wait. Instead, we rewrite that as ln of 3 is equal to x in exchange of the logarithm with the base e. And actually, most people call or read this as ln. Ln of 3 is equal to x. Stands for natural logarithm or logarithm in natural. Interchange. Okay, so if we have ln of 3 is equal to x, it is understandable that we have logarithm with the base e. Okay, so what is e? Yeah, you keep asking me, right? So if you still remember in exponential functions, we have a exponential constant e, which is the value is equal to 3.71. Approximately 3.71. Actually, it has another numbers that is followed by this one. I'm not sure if it's 81718, but in two decimal places, in the hundredths place, it is approximately 3.71. So we have here 3 kinds of logarithm. Just keep that in mind. So this is actually just these things is actually an introduction for logarithm, especially that um, it is actually difficult since it's not really in your what's this regular class if you are a regular class, but if you're in science class and you have enriched mathematics, I guess you have this lesson, logarithms. And I know that most of you didn't have any special classes in mathematics. I think that this lesson is very, very important. So as of now, that is the introduction for logarithm. I hope you learn about this simple video. Thank you very much and see you again for the next video. Peace out.